Hello Internet. Today I'm going to start a new series where I will be prototyping asteroids. So what I'm using is this is just Chrome and this is Sublime Text. So I'm going to start off with just a basic HTML file. Sublime Text has a really nice autofill where I can just type HTML and tab. We'll give it a title, asteroids, and then we will load a script. And the script will have a source equal to JS slash asteroids, nope, oops, fun with autocompletion, asteroids.js. Alright, and so that will load this. We can just go log loaded and run it, and we see we've loaded. Alright, so the first thing I'm going to do is build a tiny little game engine, and my game engines usually revolve around a vector class. So if you're not familiar, a vector class is, or a vector is just a object with an x and a y axis. In math, it's used to represent directions or a point in space on a grid. This dot x equals x, this dot y equals y. And then I'm also going to give it m for magnitude, set it to 1 for starts. It won't be set unless you set it, but we'll get to that. So every vector needs an add. We'll add a new vector to this one. I forgot, I need to return this on every single one of these so we can chain method calls together. So add, obviously, this dot x plus v dot x, this dot y, plus equals v dot y, and return this. And will we use subtract? I think we used subtract once. This dot x minus equals v dot x. This dot y minus equals v dot y. Turn this. I need one that clears it. This dot x equals 0. This dot y equals 0. And then I need a copy to copy a different vector onto this one. This dot x equals v dot x, this dot y equals v dot y. Return this. What else do we need? We need to know the direction this vector is facing. We do that by returning math.atan2 of this dot y comma this dot x. To find the magnitude, we will set this dot m equal to right, that is a squared plus b squared equals c squared. So math dot square root of this dot x times this dot x plus this dot y times this dot y, and then return this dot m. The reason I do it like that is if I need to make multiple references to the magnitude, I only have to call mag once. And at a particular time you'll have to do that when you call a unit, or is when you would like the unit vector, which makes the magnitude equal to 1, and it basically strips the length, and you're only left with the direction because the length becomes 1 of a vector. So to do that, we take this dot x. Oh wait, no. First we need to find the magnitude. This dot mag, and then this dot x divided by this dot m, and this dot y divided by equals this dot m, and then return this. I'm probably missing one. I know I'm a vector from direction, v from d. So I'm going to take it, input a direction, and it will turn this vector into that direction in a unit vector, no less. So to do that, this dot x equals math dot cosine of the direction, and this dot y equals math dot sine of the direction. And then there's one other I need that should go up here, which is scale by a number. And this dot x times equals n, and this dot y times equals n, and then return this. And I think that's all that I normally put in my vector. And so the next thing our micro engine will require is an actor class. This will basically be everything that you see on screen, well, not including text, I suppose. This is all the game objects. Constructor, it will take an object O. So it's going to need this dot an ID equals object ID plus plus. I'll make an object ID in a second. This dot type equals O dot type, and then this dot position equals a new vector. This is why I made a vector class first. This we need to set this to O dot x or 0, O dot y or 0. And this dot, oh wait, I can just do that because it's already being set to 0 right there. So I don't need to or 0 it there. So I'm also going to need a velocity equals new vector. This dot acceleration equals new vector. We're going to need acceleration speed equals, let's say, 100 pixels per second squared. That seems like a lot. Let's go 50. I can't remember. This dot direction, because in Asteroids the main character rotates, so we need to know what direction it is, and it's not a function. We'll set it to 0. This is in radians with 2 pi equaling 1 full circle, 2 pi radians. And then we will need this dot turn speed equals, this will be in radians per second, I think. If we go 2 pi, so 6.28, it'll turn a full circle in 1 second. That actually seems kind of slow. We'll see. I think that one should be closer to that. Alright, what else do I need here? The bullet is going to need a life. This will be in milliseconds, 1000 milliseconds, so if you shoot a bullet, it will stop. And we're going to make it disappear after 1000 milliseconds. I feel like I'm forgetting something there, but we'll come back to it if I am. I need more space in here. Alright. Actors will need an update function. Update takes delta time. We'll need a render function, which takes a drawing context. I think that's all for now. So the update, we need to update the position. So this dot velocity dot add. Right, we're gonna need a temporary vector as well. So I'll go down and make a couple variables down here. So let temporary vector equals new vec. Oh, the ID. That's what else I needed. Obj ID equals 0. I think that should be a lowercase o. And here, there should be a lowercase o as well. Alright. So, I'm going to take the temporary vector and use it to copy the acceleration so that I don't actually change the acceleration when I scale it to the delta time. Delta time is just how much time has passed since the last update cycle, which is going to be set to 60 frames a second. The update cycle is separate from the actual time that passed, but we'll get to that later. So we add the acceleration to the velocity. Let me take this dot position dot add, and then we use the temporary vector again to copy the velocity now, so we don't change it when we scale it down to delta time. It changes the temporary vector instead. And then when we're done, we clear the acceleration. You have to reset the acceleration every single frame or it starts to get really, really fast. I think that's all we really need to get things moving. And then for now, we're just going to draw a square. Dot fill style equals red. CTX dot. We need to translate to this dot x, this dot y, and then we need to rotate to this dot direction. And then first we need to save and restore the context, though. Might as well do that first. ctx.save and ctx.restore. And then finally we draw ctx.fill rect, and since we want to rotate from the center, we position it at negative this dot width over, that's what I forgot. This dot width over 2, negative this dot height over 2, and it will be this dot width wide and this dot height high. Now we'll go back up here and give it a this dot width equals object dot width or 16, and this dot height equals object dot height or 16. Alright, so I think that's all we need to get this started. We're going to need a canvas now. So first I'm going to make a function that returns a canvas, and it's going to take the width and height, and we're going to default to the inner width and inner height. And I forgot an equal sign there. And so I'm going to make a couple cached instance variables, one being CNV, one being CTX. That's all for now. I'll make more of those later, just so I don't have to create them. CNV equals document dot create element canvas, and then CNV dot CTX equals CNV dot get context 2D, and then we set the width and height. CNV dot width equals W, CNV dot height equals H, and then we can return the CNV. Alright, now we need our actual canvas we're going to make, so we go canvas equals canvas. We're just going to make this one that size, and then we can document dot body dot append child the canvas. Alright, so now we're going to have a canvas on screen. We haven't drawn anything to it. I'm going to start making some game loop part of the engine. So I'm going to make a function called tick. I'm actually going to move this down a line. Equals, it takes the time stamp. And then we're going to need an update function which takes delta time. And we're going to need a render function which takes the context. and that should be good for now. So tick. This is going to request animation frame. Right, tick needs a couple other variables to make it work. Request animation frame tick. But only if we're running, just so I can turn this off. My computer's really old, and if I leave it just updating while I'm typing, it gets kind of slow. Not happy with me. So we need to know if we're running, which we're going to start not running. And then we need to know the elapsed time equals 0, and the, no, not delta time. I need that as a constant. I'll remember in just a second. I'm going to add a couple constants up here, though. Those being the title equals Asteroids, and the size of everything we make. This is going to be the size equals 400. That's going to be our play space. The canvas is going to fill the whole screen, so we're not going off the sides at all. But our play area will be 400 wide, and the other one I was going to make was delta time equals 1000 divided by 60, or 60 frames a second, 60 frames per 1000 milliseconds. Alright, so where's tick? Tick is right here. So we're going to go, that's what it was, last time. Last time equals 0. So if we're running, we're going to continue running. And then elapsed time, we need to add to it timestamp minus last time. So this is just going to add to elapsed time any time that has passed since the last time we checked, and then we're going to set the last time to now. And then if the elapsed time is greater than our delta time, we call update for delta time. Updates delta time, and then we need to subtract delta time from elapsed time to represent, oh, that's not quite right. Not if, it's while. So as long as elapsed time is still greater than delta time, if it's like 3 times it, it will call update 3 times. And then we just call render once with canvas.ctx. Alright, so if I call tick, we're not running, it will just call render. And from render, we want to, actually, both of these, we don't have a player yet. We need to make a player. Alright, so this is sort of set up, and then here's like our game loop, and let's go down further and start making game objects. Player equals new actor, and we need to put an object inside that. We're going to make, we want it to appear in the middle, so we're going to set this to size over 2. This is one of the reasons I put the size there, so I don't have to write it over and over, and if I change it, I only have to change it once. Size over 2. 16 by 16 rectangle is fine for now. In fact, I think that might be all we need for now. We're going to go player.render, going to pass in the CTX, the context. First we need to fill the background though. Going to go ctx.fillStyle equals everybody's favorite web color, cornflower blue, and then ctx.fill rect 0 0 inner width, inner height. That will fill the entire canvas. I could go canvas.width, canvas.height too, but whatever. So will that, let's see what that does. I go over here and reload, and it's not doing anything. What have I done? Oh, I haven't called tick. That's what I haven't done. So after this is appended, call tick, and I want to pass in delta time, so it's not expecting nothing. We're not getting nothing. There we go. It's drawn right in the corner, though. That's because, as I often do, when I translate, I forget that I have a position vector, because I'm used to always just go this.x and this.y. I could put in getters that would do that for me, but there, and now it's right. Well, it's not in the center. It's in the center of the stage. You can't see the stage, though, because I haven't made a stage yet. So let's make the stage before we make the player. Stage equals new actor. And the stage is just a dummy. It's just so we know where things are and how big things are. But it's going to have an X. So we want to center it. So we're going to go canvas.width over 2 minus size over 2, because the size is going to be the width and height of the stage. And y equals canvas.height over 2 minus size over 2. And again, I could have just used inner width and inner height there, but I didn't. So, and then width is equal to size, and height is equal to size. And now in render, after we've already colored the background, we're going to go ctx.fillStyle equals black, because space is black. And then we're going to translate. I need to save the context. ctx.save and ctx.restore. And then now we translate to the stage.position.x and stage.position.y. And let's ctx.fillRect. Since we're already moved there, we go 0, 0. I could go stage.width, stage.height, or I could just go size, size. Actually, I just recalled I want to do this differently. Let's see, that's the result you get, but if I go to my player and set it x0, y0, you'll see that it draws it outside of that. So the way I need to do this is instead ctx dot, I need to begin a path, and then instead of fill rect, we just rect, make a rect, and then we can ctx dot fill, but we also need to ctx dot clip, because that will make everything we draw after it before we restore the context clip to this rectangle. So that should, when I save it, come over here, and you can see that it cuts it off at the corner. So let's move our player back to the center since that test was successful. Alright, let's, just to make sure things are working a little bit here, let's make an object start with a bit of velocity. Make it 10 by 0 and see what happens. And it is not updating because I didn't go update here. So I need to go, oops, player.update delta time. That reminds me, I need to come up here. This delta time that it passes in is going to be in milliseconds. It's going to be about 16.6667. That's not what we need up here. Up here, we need this over 1000 and over 1000. I still need the 16 a little bit later, so that's why I don't just pass it in as over 1000, but that should hopefully give us some movement. He's not moving very fast. Let's make it faster. Oops. No, I'm not updating. Because, let's see, oh, that's because it's only being called once because running is set to false. So if I set running to true, now it will work. Yay, it works! So, now that that's working, I'm going to quickly do one other thing here, I'm going to make it wrap around. So if this dot x is greater than size, I need an if statement. See, this is, my fan is like starting to turn on here, so I'm going to set this to false. And I'm just going to comment that out quickly and go reload this so it is not still updating. There, if this dot x is greater than size, then this dot x minus equals size. That'll move back to the, if it moves off the right hand side, it'll move back to the left hand side. And the other way to do that is if this dot x is less than 0, this dot x plus equals size. And then I'm going to do the same thing, but with y. Set that to y, and need to set this to true. And it should flip. It doesn't. Why didn't it? Let's set that back to false. Reload here. Because, as I do so often, forgot that is not this dot x and this dot y, it is dot position dot x and this dot position dot y. Oops, I need to set this to true. And it wraps around. It wraps around, hooray. Let's set this to false. And stop pressing Control R there, or Command R. Alright, so I think that's where we're going to end the first episode.